Now, for a polynomial, what most determines its shape on a graph is actually its lead term and its degree. So what do I mean by in behavior? Let's take a look at an example first, and I'll explain the example. So here's a graph of x squared and x cubed. Notice that as x gets larger, both x cubed and x squared will approach infinity. As x becomes more and more negative, x cubed will go downwards towards negative infinity, and x squared will go up towards positive infinity. In behavior is how a graph acts as x moves to the right or to the left, i.e. as x becomes very positive or very negative. Let's be a little bit more clear. So this is written out. We have f of x equals x squared, and by in behavior we're talking about the behavior of a function f of x as x moves to positive infinity or negative infinity. In this case, as x goes to infinity, so as we move x way to the right, f of x approaches positive infinity as well. Okay, as x goes to negative infinity, f of x actually approaches positive infinity as well. And that should make sense because whether you take a very large negative term or a very large positive term, if you square them, they're both just going to be really big positive numbers. All right, so let's generalize this to any polynomial, what the in behavior will be. Our first case is when you have a positive lead term. Remember that a positive lead term is when you take the largest power of x, you look at its coefficient. That's the lead term. So this is the case when we have a positive lead term. Now from this, we actually have two subcases, and that's whether the polynomial is of even degree or of odd degree. If the polynomial is of even degree, then the graph is going to shoot upwards as x moves to the right or to the left. An example of an even degree positive lead term would be x squared, the graph that we just did. So let's write that down. All right, so just like before, as x approaches infinity, f of x will approach positive infinity, and as x approaches negative infinity, f of x will still approach infinity. On a graph, that means that to the right or to the left, if you move far enough over, you're going to be going up in both directions, just like our x squared graph. All right, next, if f of x is of odd degree with a positive lead term, here's what we get. So as x approaches infinity, f of x will approach positive infinity. Then as x approaches negative infinity, f of x will approach negative infinity as well. That means that on the graph, to the left, we'll be going down, and to the right, the graph will be going up. We're not so concerned with what happens in the middle here, because right now we're just talking about the end behavior of the graph. So what happens at the extreme right and left. All right, next, negative lead terms. All right, we've got it all changed over. Let's review the changes. For an even degree polynomial with a negative lead term, as x approaches infinity, f of x will approach negative infinity. Same for x going to negative infinity, f of x will also go to negative infinity. So that means that in both directions, to the right or left, your graph is going to be going down. All right, next up, odd degree negative lead term. As x approaches infinity, so as the graph moves to the right, f of x approaches negative infinity, so we're going to be going down. And then as x approaches negative infinity, f of x will approach positive infinity. So our graph will shoot up as x moves to the left. Now let's show just a couple examples using actual polynomials. All right, so let's determine the end behavior of this polynomial. We've got negative 3x to the fifth plus 4x squared plus 2. That's our f of x. Now let's determine what degree and what the lead term is. The degree, the highest exponent of x for this, is 5. Now the lead term, the coefficient associated with that power of x, is negative 3. All right, so negative lead term, odd degree. That means that our graph goes up as we move to the left and down as we move to the right. So this would be our appropriate end behavior. Let's try one more example. So in this one, we've got 4x squared plus 3x to the fourth plus 2 equals our f of x. So let's identify what the degree and lead term are. So we've got 4x squared, 3x to the fourth. Here's our highest exponent of x. So our degree of this polynomial is 4, which is even. And then our lead term, the coefficient attached to it, is a positive 3. All right, positive lead, even degree. That means that we go up as we move to the left and the right. So that would be our in behavior. Our graph would be expected to shoot up as we move to the right or to the left.